So we are doing velocity of transverse wave on straight string. So say this is a straight string, a portion of the string through which the wave is moving, and we consider a small portion of it, say of length dl, okay, and say it subtends an angle say theta over this whole region. Say theta na nahi, let's divide into two equal parts. Say exactly through the vertical line. Say this part is theta and this part is also. Alright. Now, what happens when you pluck a rubber band at the middle? You have seen it goes up and down, vibrate karta hai, right? So when it vibrates, it actually is producing waves which are getting reflected from the two fingers at your two ends and then overlapping, and that creates the stationary wave over that region. Okay. Now the question is, ये stationary wave का velocity कितना है? How do we find out the velocity? আরেকটু দেরি করে আসতে পারতিস তাড়াতাড়ি। So for that, how do we find out the velocity? Say this point, the tension is directed tangentially, T over here, and over here the tension is T. So if we find out the two components of the tension, this is T over here, so it will have a horizontal component and a vertical component. Now how do you find out the horizontal and vertical component? If this angle is theta, this angle is also theta. So if this is theta, this angle is 90 degree minus theta, right? And then this angle is, so this T will have two components. Along this direction it will be T, and along this direction it will be, the same thing will be over here, T cos theta and T sin theta. Now see, this T cos theta and T cos theta are equal and opposite, so they balance each other off completely. What happens with these two T sin thetas? They produce the necessary centripetal force. Why? Because this is forming a circular path, and actually the string is pulled towards the center. So that's why we'll say that this T sin theta and this T sin theta is producing the net centripetal force. Now the question is, we write 2t sin theta is equal to mv square by, question is, what is r? V is the velocity we need. V is the tangential velocity we need. R is the radius. Now that is not known to us. How do you get to know that? Say this length over here is L. Okay? Right. So we use the formula S equal to R theta. If this angle is theta and radius is R, then L is equal to R into, so you can say R is equal to L by, right? L by theta. So we can write, since theta is small, we can write sin theta nearly equal to 2t theta equal to mv square by r. R is L by theta. So this will be theta by L. Yes or no? So now theta and theta cancels off from both sides. Oh, there's a small mistake we did. The mistake is this whole angle we are considering, right? This will be it will be due to 2 theta length. Okay, the mass due to 2 theta length. Otherwise, this we are taking this t cos theta over this range. Say this L portion is having a mass m. Tahale this whole length will cover a mass of twice m. ঠিক আছে? সেজন্য নালে it will create a problem. তাহলে এটা কি হচ্ছে? তাহলে v square will be equal to কি? 2 দিক থেকে ক্যান্সেল হবে, t by m by l. So v equal to under root of t by mu. What is mu? Mass per unit length. T mu is mass per unit length. Is that clear? তাহলে এই যে v is equal to theta equal to একই ব্যাপার, ঠিক আছে? So v is equal to root over of t by mu আসছে. This is called the velocity, মানে this is how we find out the velocity of any wave on a straight string. So the velocity is directly proportional to velocity of wave is directly proportional to square root of tension and is proportional to 1 by square root of mu. Mu is what? Mass per unit length. Remember, it's not mass, it's mass per unit length. Okay? Now, knowing this concept and the stationary waves on the straight strings, stationary waves on the straight strings, we have only discussed nodes and internodes, right? So, nodes or antinodes, sorry, nodes and antinodes, and how to work with them, shit, I'm going to discuss. Velocity of transverse wave on straight string, ये समझ में आ गया?